The Student Survival Budget System is a C++ program developed to help university students manage their monthly finance more effectively. Managing pocket money can be challenging, so this system records monthly income and expenses, automatically calculate the remaining balance, and provide warning alert when spending exceeds the planned budget limit. The main goal is to encourage better budgeting habit and reduce financial problems at the end of the semester. We developed this system with three main objectives. First, to help university students plan and monitor their monthly budget effectively. Second, to accurately calculate the total income, total expenses, and the remaining balance. Third, to provide budget warning alert and financial summarize that help students make smarter finance decisions. Next is the analysis phase. Before writing the code, we designed the system using an IPO chart, which stands for input, process, and output. This chart helps us organize the program logic and ensure that the data flows systematically, making the system easier to develop in C++. This IPO table forms the backbone of our program. For the input, the system collects the student name and ID, monthly income as a budget limit, the number of expenses category, the category's name, the amount spent for each category in Malaysian ringgit, and the budget warning threshold percentage. For the process, the system validates all user input, calculate the total and average expenses, identify the highest and lower expenses category, and determine the budget status as safe, warning, or deficit. Finally, for the output, the program displays the total budget summary, including the total expenses and remaining balance, average spending, the highest and lower expenses category, the budget status, and recommendation to help students manage their finance more effectively.
Let's break down the logic step by step. We begin our pseudocode at the start block with our variable declaration. To keep data organized and accurate, we use specific data types. The student identifier are kept as string. Financial data like the monthly income, total expenses, balance, and average are declared as double to handle decimal currency value accurately. To track multiple items efficiently, we initialize two parallel arrays with a maximum size of 10 elements. Expenses name to hold text description and expenses amount to hold the respective cost. Finally, we use integer like max index and min index to act as pointer for our analytical phase later on. Moving into user interaction, the program grades the user and captures their basic profile data. Right after, we implement our first layer of data validation using defensive programming. We use a post-test do-while loop to force the user to input a valid monthly budget. If they enter a zero or negative amount, an error message triggers and the system loops back until a realistic income is entered. We follow the exact same validation logic for the category selection. Student can log anywhere from 1 to 10 distinct items. The system will continually trap the user in a do-while loops until they provide an integer within that specific boundary. Once bounds are established, the program enters a definitive interaction block using a for loop running from index 0 up to expense count -1. For each interaction, the program dynamically asks for the name of the category, such as rent or food, and save it to the name array. Then, using a next do-while loop, inside the loop, it's prompt for the spending amount. This next check ensures a student cannot accidentally input a negative expense, preserving the integrity of our calculation dataset. With the data cleanly stored in our parallel arrays, we move out of data collection into calculation. Rather than cluttering the main flow, the script relies on clean modular design by executing several call statements to sub-functions. First, calculate sum and calculate average, process the array to derive total outlays and average spend per category. Next, we pass our tracking pointer, max index and min index into the find highest and find lowest function. This function swap the array's location, the higher and lower spending figure, and update those pointer variable back in the main sequence. The net balance is calculated simply by subtracting the total expenses from the monthly income. Finally, the system output comprehensive format financial report statement. It cleanly displays the user details, their total breakdown, remaining balance, and use the save max index and min index value to explicitly print the actual names of the students' highest and lowest financial drains. To conclude the execution, an evaluation engine run an if-then-else condition structure to assess financial status. If the total expenses surpass the budget, it flags a severe red alert critical overspend. If the student hasn't gone over budget but has consumed 85% or more of their available pool, it's triggered a warning state. If they remain safely under that 85% their holds, they receive an excellent status confirmation before the system officially hits the end block. Next, we move to the flowchart. Let's start at the start symbol. The program begins by preparing everything it needs before collecting any information. Here, the system declares all the variable and arrays needs, such as the student's name, ID, monthly income, total expenses, balance, and array to store up to 10 expense name and amounts. Next, the user enters their basic information, which is the student name and student ID. After that, the user enters their monthly income or allowance. The program checks whether the income entered is valid. If the value is 0 or negative, it displays an invalid amount error and asks the user to enter the income again. This error message appears because income cannot be 0 or negative. Once the income is valid, the user chooses how many expense categories they want to record. The system checks if the number of expense categories is between 1 and 10. If not, it shows an error message. This prevents the user from entering an unrealistic number of expense categories. The input buffer is cleared to make sure the next input is read correctly. This is the loop condition. The program repeats the following step until all expense categories has been entered. The user enters the name of expense category, such as food, transport, or books. Next, the user enters the amount spent for that expense. The program checks whether the expense amount is negative. Negative expenses are not allowed. If the negative value is entered, the system displays an error and asks the user to enter the amount again. After displaying the error, the program loops back to the input expense amount I step. This allows the user to re-enter the expense amount until a valid, non-negative value is provided. If the amount is valid, the program prepares for the next expense and increases the counter. After increasing the counter, the program loops back to the decision I less than expense count. If there are still more expense categories to enter, the loop continues. Otherwise, the program exits the loop and proceeds to the calculation stage. After all the expense has been entered, the program calculates the total expense, average expense, highest expense, lowest expense, and the remaining balance. The program then displays a financial report containing the student's information, income, total expense, balance, average spending, highest expense, and lowest expense. Now, the program checks if the total expense are greater than the monthly income. If the expenses are higher than the income, the program displays critical overspend, meaning the student has spent more money than they have. If the student has not overspent, the program checks whether they have used at least 85% of their monthly income. If the spending reaches 85% or more of the income, the program shows warning near limits to remind the student to be careful with their remaining money. If the student spends less than 85% of their income, the program displays excellent save, showing that their spending is well managed. Finally, all the paths lead to the end symbol, which means the program has completely successfully. Thank you for listening.
Hello everyone. Today I will walk you through a demo of how to run and test our student survival budget system in C++. First, we compile and run the C++ code The system display the title banner Student Survival Budget System. It then asks us to create student profile. Enter the student name exactly as prompted. I will enter Siti Alia binti Zulkifli. Now, next, enter the student ID. Now, the program asks her for the monthly budget. For this test case, we will give our student a budget of RM600. Next, it asks us how many expenses category we want to log. For this demo, let's track 4 key categories. So, I will enter 4. Since we enter 4, the program will loop 4 times. We need to enter the name of each category and the amount spent. Category 1, food, amount spent RM330. Category 2, transportation, amount spent RM46. Category 3, stationery, amount spent RM25. Category 4, entertainment, amount spent RM200. Once we enter the final amount, the system processes everything and outputs a comprehensive financial report statement. Here's the report. Financial report statement. Student name, Siti Alia binti Zulkifli. Student ID, 225 952 834. Monthly allowance, RM600. Total expenditure, RM601. Remaining balance, -RM1. Average spending, RM150.25. Highest drain, RM330. Lowest drain, RM25. Status, critical overspend. The system correctly flagged this as critical because the remaining balance is negative. And that's it. This demo shows how the student survival budget system tracks spending, calculate total, and alert students when they overspend. Thank you for watching.